In this video, we will see how we can make 15-meter pan-sharpened image from 30-meter RGB image of Landsat image collection using 15-meter panchromatic band of same image collection. First, we will select the area of interest. We have used a point geometry as our area of interest. You can change this coordinate value according to your location, or you can select from the map using this add a marker point marker. Now from Landsat collection we will select one list cloudy image. For that we made one variable named image, and in this image we put the image collection, that is ee.image collection and Landsat image collection. If you want to search for the image collection, you can search here Landsat, and we use this one Landsat 8 collection to tier 1. You can select this and copy this snippet, and you can also go for some information, bands, image properties and other things. Let's close it now. After loading the Landsat image collection, we filter with our boundary filter bounds with this point. This filter bounds algorithm will select all those image styles which has an intersection with our point. Then we filter our collection with date from 1st July 2019 to 31st July 2019, and then sort all the images based on cloud cover so that the least cloudy image will come first. And we have selected the first image, which is least cloudy. Now from this image we will select RGB and panchromatic bands. We made two variables here. First one is for RGB, and we select the B4, B3 and B2. B4 is for red band, B3 is for green, and B2 is for blue. And select the panchromatic band, that is B8 in Landsat collection. Now we will apply Brovey Transform method to Pansharpen this image. Now let's see how Brovey Transform technique works. It is used to Pansharpen satellite image using fusion of high resolution panchromatic image with low resolution RGB or multispectral image to produce a sharpened color image. We already have said that this is a Pansharpening technique. It combines high resolution black and white image, which is panchromatic, and lower resolution color image, that is RGB. Why we use Brovey Transform method? To make satellite image sharper and more detailed, especially useful when we want to enhance color images using special details from panchromatic bands. Now let's see the steps. How does it work? It first takes the RGB image and add them together to get total brightness. Divide each color band by total to normalize the bands, and then multiply the result by the high resolution panchromatic image, and compared to the RGB image, the final result is much sharper and vivid. Now let's see how Brovey Transform calculation process works. First we need the RGB image, so red band, green band, blue band, and panchromatic image, that is black and white high resolution image. If we consider for Landsat 8 image, the RGB image resolution is 30 meter and panchromatic high resolution image is 15 meter. So we can convert 30 meter image to 15 meter. The first step is sum of RGB bands, that is total addition result of red band, green band and blue band, and this is done for every pixels. So after calculation of this sum, we will get the summation result of red, green and blue band of every pixel. And then the second step is normalize each band. So we will normalize each band's value dividing by this summation result. First one is red normalized, red divided by sum of red, green, blue, and likewise green and blue normalized bands. And keep in mind that this result is different for every pixels. It is calculated pixel wise. And the third step is multiply with pan bands. This means this normalized value will be multiplied by the pan image, since panchromatic image is 15-meter resolution. So our converted or final image output will be 15-meter. It will be sharpened red, sharpened green, and sharpened blue bands. Those sharpened bands make our final high resolution RGB image. And finally, Brovey Transform output. What does it do? It preserves the color but adds fine spatial details. So finally, image will be color and clear. But we should keep in mind that this is usually used for visuals. It's not ideal for scientific analysis, because color values that is calculated from the RGB may be slightly altered. Before applying Brovey technique, we convert our RGB image value to float value. It is usually integer value. So we divide our RGB value with a float number, which converts the values to float. Now let's apply the Brovey transform. We made a one variable named sum and put the RGB images summation value into it. We used reducer e.reducer.sum. This reducer actually calculates the summation of red, green, and blue bands that is needed for Brovey transform. And then we make another variable named Brovey, and here RGB image is divided by this summation value and then multiplied by the pan image, and finally rename as B4, B3, B2, which is usually Landsat images band name. And finally, this is time for visualization. We center our map to the image and then add the RGB image as a layer, original. We name it original RGB layer, and minimum and maximum value is 0 to 0.3, which is usual value. We can adjust these values later. And then add the panchromatic band and name it panchromatic 15-meter. And finally, we add our Pansharpened Brovey image, the name of the variable, and then minimum maximum and the name we have inserted. Now let's see how it looks like. Let's run the code. The image is little bit darker. Let's change some visualizations. From the range, let's select the stretch 3 sigma and apply. It should clarify the image a little bit. Yeah. Now our image is much brighter. Close. And then this one, we could also apply stretch function here, and it is also looks good. And the original image, let's make it also 3 sigma and apply. Now all of our images brighter. Let's check some features. You can see that the original image is visualized, but the pixels are bigger, so image is not that clear. Let's turn on the panchromatic image and see. If we move the slider, you can see that the panchromatic image is much clearer than our original RGB image for Landsat. Since panchromatic image has higher resolution, we applied the Pansharpening Brovey technique to make the panchromatic image as a color image. Now let's turn off this and see our Pansharpened image. Let's move the slider so that you can easily classify how images has transformed and how good the new resolution is. You can see if we turn on the Pansharpened image, it looks quite good. Let's make a little bit zoom. This is original Landsat image RGB, and now we will show our Pansharpened image. You can see that new image is much better than the previous one. Thanks for watching.